Good afternoon, students. Students, in our last classes, we have seen about different type of channels that are being used in the field of information theory, and we have also seen their channel matrices. Today, we will try to develop a relation for channel capacity, and apart from that, we will find out the channel capacity of BSC. That is the most important topic, that is channel capacity of binary symmetry channel. So let us first of all develop the basic formula for finding channel capacity. But before going to that point, I will like to remind you about the formulas that we have studied till now. So we have studied in our last class that the formula for joint probability is Pxi, Yj. This is called as joint probability, and the formula for joint probability is Pxi into Pyj slash xi. This we have done in the numerical as well, that whenever we want to find the joint probability, what we will do is we will multiply the input probability with the channel matrix. So this is how we find out joint probability from transmitter side. Similarly, if we are on the receiver side, we find it using Pyj into Pxi slash yj. So this is the formula for receiver side to calculate joint probability. So from here we can find the value of Pxi slash yj. So the value of Pxi slash yj will be equal to Pxi comma yj upon Pyj. So this is the formula for Pxi slash yj, and I am donating it as 1 because we will be using it inside our formula to develop channel capacity. Now we know we are going to make a general relation for finding channel capacity. So we already know that the channel capacity is equal to maximum mutual information. Now what do we mean by mutual information? That is I x semicolon y is equal to hx minus hx slash y, or we can also write it down as hy minus hy slash x. So this was the relation for mutual information, and the maximum value of mutual information will give us channel capacity. So let us say we will be developing the formula with the first relation, that is hx minus hx slash y. We all know hx stands for source entropy. This is called as source entropy, and its value is summation of I Pxi log base to 1 by Pxi, where I stands for number of input sources. Similarly, J will stand for number of outputs. I stands for number of inputs and J stands for number of outputs. In case of BSC, the number of inputs are 2 and the number of outputs are 2. So in the case of BSC, both I and J will be equal to 2. But now we are making a general formula, so we will write down as I and J. I means number of inputs and J means number of outputs. So I will write it down here. I is number of inputs and J represents number of outputs. Okay. So now we will write down the value of hx slash y, that is called as, this is hx slash y. This is called as joint, or this is called as conditional entropy. Hx slash y is called as conditional entropy. It is also called as average uncertainty that x has been transmitted when y has already been received. This is called as average uncertainty. That means entropy and conditional entropy. Because y has already been received, then what were the chances x has been transmitted? It is given using formula, as we have already discussed, summation of I, summation of j, P xi comma yj, that is joint probability, log base 2 1 upon p xi slash yj. So this is the formula for conditional entropy. So now we will write down both the formulas, hx minus hx slash y. So we will put the values of both of them in mutual information, that is ix semicolon y. So this is equal to summation of I pxi log base to 1 by pxi minus summation of I summation of j pxi comma yj log base to 1 by pxi slash yj. So now we know कि whenever we can write down this pxi as summation of I is already there, and if we will replace with one more summation, that is summation of j p xi comma yj. If we will sum joint probability for all values of j, as we have seen in the numerical earlier also, if we will change the values of j for joint probability, that means this will represent one row, this will represent ith row, है ना? So this will represent ith row. That means probability of input, probability of ith input, है ना? So this is what I have written down. I will replace pxi with joint probability xi comma yj, and then I will summation, put a summation sign of j. That means one row of joint probability that will give input probabilities. ठीक है ना? Into log base 2 1 by pxi minus summation of I summation of j pxi comma yj log base 2 1 by pxi slash yj. Rest all the things are same, pxi slash yj. So now in both the places pxi comma yj is same, so we will take it common. Summation of I summation of j pxi comma yj has been taken out common, and we are left with log base 2. This is in minus, so it will move upside, that is pxi slash yj will go in the denominator and pxi will remain as it is in the denominator. So now before starting the formula, I have told you the value of pxi slash yj. So here if you will see, in the first step we have written down the value of pxi slash yj. So we will take the value from equation number 1 and we will put this value here in pxi slash yj. So this is equal to summation of I j pxi comma yj will remain as it is, log base 2, instead of pxi slash yj we will put down its value, that was pxi comma yj upon pyj. This is the value of xi slash yj divided by pxi is already there. So now we know the value of joint probability, that is pxi comma yj, we know its value. This is equal to summation of I summation of j pxi comma yj log base 2 pxi into pyj slash xi. Why I have done this? Because I want to make each and every term in channel capacity, in channel matrix form, that is yj upon xi. Because in questions in numericals we will be always be given joint, we will be always be given channel matrix. So we want to convert xi comma yj into yj slash xi. So this is pxi into pyj slash xi divided by pyj into pxi. So I will cut xi and xi. So now, till now we have reached to this point. I will write down the last step again, that is summation of I summation of j pxi comma yj log base 2 pyj slash xi upon pyj. So this was the last term that we have seen, joint probability log base 2 channel matrix upon Pyj. So here also we have written the same thing, that is joint probability log base 2 channel matrix upon Pyj. So now how we can represent this Yj? We can write it like this as well, that this is equal to summation of I, summation of j, Pxi comma Yj, this is as it is, into log base 2 Pyj slash xi, this is also as it is. Now I will replace this Yj with summation of I Pxi comma Yj. If you will remember, in the numerical I have told you that if we will add the joint probability column wise, we will get output probability. So output probability is equal to summation of column, summation of one column of joint probability. So this is what I am doing. I am changing the values of x, but y value is constant. y1, y2, it can be constant value. So the values of x will change, that means column will change. This means the sum of one column of joint probability is there. So this is equal to output probability. If you will see the numerical that we have studied in our last 2-3 last lectures, you will be able to find that we can write Yj, that is output probability, like this in joint probability form. So hence we are able to reach our formula, that is Pxi. I am writing this joint probability as Pxi into Pyj slash xi log base 2 Pyj slash xi upon summation of I Pxi Pyj slash xi. So this is the complete formula for calculating mutual information, that is Ix semicolon y. So this is the formula, and from this formula we will be finding out the channel capacity of BSc in our next class. That is the one of most important question of our syllabus. Thank you students, thank you for your time. Please revise the previous lectures as well.